So when we are talking about solving the system of equations, normally there are, for example, 3 variables, 3 unknowns. It is very difficult to substitute the variables one by one, but by chance, if the equations were made of like one equation is only one unknown, for example, in this third equation there is only one unknown. That's why it's possible to solve x3 from here. So x3 is equal to 4 over 2, which is 2, right? So if it is known, then you go up and then you see that this is known. Then you are able to find x2. Once you know x2 and then you already know x3, you are able to find x1. It means if each equation has only one addition to the unknowns, it is easy to substitute and solve them easily. And this is the reason why we are trying to eliminate the variables to make it easy to solve. So we are doing this process by Gauss elimination. Gauss elimination. So this is the structure we are trying to come in. So when there is for example, this is more unknowns, and we don't care how many more unknowns are there, because for each equation you are able to just solve one unknown, and from there you go and find the other unknown. Once they are known, then you can find the other one, and then you are able to find all of them. So it means the size is not important. Important is to make them triangle shape. So when we have system of equations which number of unknowns for each equations are existing, means it doesn't look like triangle. It means every equation has 3 variables. Then by eliminating one by one and trying to substitute is practically difficult. But when we are using a matrix system, first we take the coefficients and make the coefficient matrix, and then technically this times x1, x2, and x3 is equal to the b, which is 3 minus 1 and 4. So this is the equation normally. This is the equation normally. Therefore, when you design the coefficient matrix by the right-hand side, which is called augmented matrix, we can do some row operations. So row operation means in equation style, you can multiply any equation by any number, and you can add any equation to another equation. So by this way, we are able to eliminate some of the unknowns in other equations. So that's why interchanging the rows, multiply a row by a non-zero real number, and replace a row by its sum with a multiple of another row. Means, in this case, for example, you want to get rid of this variable in second equation. What we do, we multiply the first equation by 3 and add them up or subtract based on the signs to the second equation. Then we eliminate the existence of the variable in second equation. And then similarly, if you multiply the first equation by 2 and subtract from the third equation, then the first variable will disappear from the third equation. Then the appearance will be less unknowns in the equation. And similarly, if you do the same thing for the other unknown, then you will end up triangular form, and which will be easy to solve the equation. So we are approaching this by saying that pivotal row means the one which you do some operation to eliminate corresponding variable coefficient. So in this case, the first variable coefficient is 1. So by multiplying get directly the same number of the corresponding coefficient in other equation, means 3 times row 1 is subtracted from row 2, can eliminate the first element of the second row, and then if you say row 3 minus 2 times row 1 will eliminate the coefficient of the first variable in the third equation. So this means we are able to eliminate the existence of the variable in second and third equation. So now we go downward, and then the pivotal row is the second row. Now we choose the second variable and then try to eliminate the existence of that one in the following rows. It means we eliminate the existence of the second unknown in the third equation. So once the appearance becomes triangular, it means if you go back to equation form, from here we should be able to easily write the equation. This can be a question also, saying that write the system of equation from this coefficient matrix. So if this is the matrix, then it's supposed to be like this. Is equal to 3 minus 10. These are same thing. So coefficient matrix is the reason why we are writing this. So from here, if it was the equation, it was supposed to be x1 times 1 plus 2 times x2 plus 1 is x3 is equal to 3 minus 7x2 minus 6x3 is equal to minus 10 minus 1 over 7x3 is equal to minus 4 over 7. So this means that, so without writing back like equation form, one should easily see that this times the third variable is equal to this time. It means from here, the third variable is equal to minus 4 over 7 divided by minus 1 over 7. And that means 4. So once it is known, it means the second variable times minus 7 minus 6 times third variable is equal to 10. So since the third variable is known now, one should be able to substitute and say, here we know that x3 is known. Let me make it red. So this is known now, and this is unknown. So by knowing x3, we are able to find out x2. Then we know x2, and we are able to find x1. So that's why it's very practical to bring the matrix in triangular form. For example, in this example, 4 variables, 4 unknowns, 4 unknowns and 4 equations. And writing the augmented matrix is easy. The coefficients are happening here, and this right hand side is here, and we are able to do operation on this matrix very easily. So if you multiply this first row by a certain number, the matrix will eventually not change. It means the equations are same equation. It means if you multiply this equation by a number, it will not change the equation. The equation is still there. So if you multiply any of this equation by any number, it will not change the equation. It means, for example, these 4 variables added up is equal to 6. If you multiply this by 3 and say this is 6 times 3, the same equation doesn't change. So it means we are able to multiply any row without any problem. And then if you add them up, also doesn't change. So if you add the first row to the second row and replace the second row by this addition term, it's still the same. So the way we do, we are supposed to eliminate the corresponding variables. So in this case, because of there should be a coefficient here to eliminate the bottom one, what we do, we exchange the rows so that the top row becomes with pivotal element. Pivotal element should be non-zero so that you can use to eliminate the bottom ones. So when you exchange them, then the second row becomes the top row, and then multiplying, I will say like this. This is after the process, of course. After exchanging these two, so the first element is 1, then the multiply by 2 and subtract from this one, multiply by 3, subtract from this one, and then eventually make this kind of matrix. Then from here we go backward and then find the fourth variable by solving here, and then go back and then put it here and then find this third variable, and similarly second variable and then first variable. So this is the process which only by practice we can master it, but there should be no any difficult part except practice. So LU decomposition is a kind of another approach to solve the equation easily. So the way we approach LU decomposition means we have the matrix of A divided into two portions. One is lower matrix, one is upper matrix. We will come back to it. Assume the three equations, three unknown, and we have a system of equations like this. In this case, our coefficient matrix is A, and variables are X, and the right hand side is B, which means we can write it in the form of coefficient matrix times variables is equal to right hand side. So LU decomposition means we have to find two matrices which when you multiply them becomes A. So in a sense, the lower matrix will be diagonal 1, and then there are three elements which we don't know yet, and upper matrix is made of matrix which is lower triangle is 0. And when you multiply them, it means if there is L and U, this means A times X is equal to B. This is the structure of it. And then when you multiply these two matrices, let's multiply it. If you multiply these two matrices, so the first element here is 1, it means the top row will be transferred as is. And then the second row is L21 times the top row plus second row. So it means U11 L21 plus 0 in this case. And the second element is L21 times U12 plus U22. And the third one is L21 times U13 plus 0 because corresponding one is 0. And then the third element here is L31 times U11 and then L31 times U12 plus L32 times U22. And the third one, L31 times U13 plus L32 times U23 plus U33. So this means this is A. So if this is equal to right hand side, we should be able to write this and the right hand side of the equation and then solve it, right, normally. But before coming to the solution, we have to find the corresponding variables here by associating this A to the real A which we already have. Because our A is a coefficient matrix and there are numbers there. So if there are numbers there, we should be able to find it easily. Yeah, let's go by example. In our example, we have three equations, three unknown, and then if you go and write down the coefficient matrix. Coefficient matrix is here, which is A, and this is X, and this is B. So now, this is the form of Ax equal to B. And now we want to decomposition of A to LU. If it is LU, lower matrix is this one, and upper matrix is this one. So in this case, before solving the equation, we are trying to associate these variables to the coefficient matrix to find out these variables so that we can write it in two matrix form, which is L and U. L and U. How we do it? We multiply 1 times this and this. We mix the top row as is. And then similarly L to 1, U to 1. And then the one we did above. And this is the third row. These are the equations. Equation is what? It means by associating the variables here, we can find out like U11 is equal to, this is equal to 1. This is equal to 1. They are all directly found easily. 1, 2 is equal to 1. U13 is equal to 1. And here it says L21 times U11 is equal to 3. Since U11 is known, then L21 is equal to 3. And from there, we go here. We say L21 times U12 plus U22 is equal to 1. L21 is already 3. U12 is 1. U22 can be written as U22 is equal to 1 minus 3, which is equal to minus 2. And then we go to this term, which is L21 times U13 plus U23 is equal to minus 3. It means L21 was 3, U13 is here, it is 1, and we can find U23 is equal to minus 3 equal to minus 6. Then we go to the third row here. Let's continue from here. We say L31 times U11 is equal to 1. Since we have L31, where are they? U11 is 1, and L31 is equal to 1. And we go to L31, U12 plus L32, U22 is equal to minus 2. And this is 1. And this is 1. L32. And U22 is equal to minus 2. From here, we find 1 minus 2 L32 is equal to minus 2. Minus 2 L32 is equal to minus 3. L32 is equal to 3 over 2. And then equation which is left, this one, is equal to minus 5. So L31 is equal to 1. U13 is equal to 1. L32 is equal to 3 over 2. U23 is equal to minus 6. And we are trying to find U33. So 1 minus 9 plus U33 is equal to minus 5 and is equal to minus 8. U33 is equal to 3. So from here, we are able to collect all the variables. So let's see, our variables are U11, U13, U12, and U13, and then L21, and then L31, and then U22, and U3, and L32, and U33. If we collect all, we will be able to find out that our matrix will be a lower matrix and then upper matrix and then x1, x2, and x3 is equal to the B. So this is lower matrix, this is upper matrix, and this is the B side. So now we assume this part as y, and then if it is y, we say our lower matrix times y is equal to B. So lower matrix is already by the values above. We can take it like from the values, we can find that it's supposed to be something like this. We found the values L21, L31 like this, L32. This is our lower matrix. And then these are the Y1, Y2, Y3 is equal to B. Our B value were 1, 5, 10. So here we are able to find the variables y1, y2, y3 easily because the corresponding equation y1 is equal to 1. From there you find y1 is 1. And 3 times y1 plus y2 is equal to 5. Since y1 is known, you can find y2. y2 is equal to 2. And from there, y1 plus 3 over 2 y2 plus y3 y3 is equal to 10. From there you find y3 is equal to 6. So now by knowing the y values, we said L times U x is equal to B. We said this part is y. Then L y equal to B. We found y's. Since y is known now, U times x is equal to y. We are able to say our upper matrix times y x, x2, and x3 is equal to y1, y2, y3, which is already found above, which is 1 and 2 and 6. Our upper matrix values are given above, so let me copy from there. From here, if you look at the upper matrix, U1, 1, 2, 1, 3, they were 1, and then 2, 2, 2, 3, and 3. So let's take it here. To make it easy, I will put it here first and copy down there. We said 1, 1, and 1, because U11, U12, U13. and then U22 was minus 2, and U23 was minus 6, and U33 was 3. This was our upper matrix. And I will copy this, bring it here, and this is our upper matrix. Upper matrix means times x1, x2, x3 is equal to 1, 2, and 6. From here, we are able to associate this equation and then find out x3, and then substitute here and find x2, and then from there you find x1. This is the way of LU decomposition method to find out the solution of these equations.